Guys, a couple people have kind of reached out and said that they're having trouble understanding the homework and the lesson that they were supposed to do from today. So I'll be available before school and happy to answer questions before school. But just in case you want to look some stuff over tonight, I'm going to try to share a few examples with you just to offer a little further understanding. And I hope that this can kind of help make some things a little clearer for you. So when we're looking at these rational functions, if we're looking at something like this, what it means is that I have a polynomial in the numerator and in the denominator. Now we know that the rule is you can never divide by 0. So it makes sense that when we go to graph it, whatever makes the denominator equal to 0 means that we can't have a graph there or have the graph continue at that point. So we care what makes the denominator equal to 0. Anywhere that the denominator is equal to 0, or any value that makes the denominator equal 0, is a point of discontinuity. So let me just I'm just making some of these examples up as I go. So let's say I have something like f of x equals x minus 5 over x plus 1, x minus 4. Okay. So I do not really care about what the numerator equals in terms of like finding points of discontinuity. For the first few problems of your homework, all you're doing is saying there is a point of discontinuity here and here. If I look at this problem, I have 2 factors that I need to set equal to 0, which means I should have 2 points of discontinuity. I'm going to take each one of those and set it equal to 0. And when I solve them, I get x equals -1 and x equals 4. This is a point of discontinuity because if I plug -1 in, even though here I would get -5, over here I would have -1 plus 1, which is 0. 0 times anything is 0, and I can't divide by 0. So if I plugged it into all those, I would end up with like -6 over 0 times -5. But that gives me 0, so that means that this doesn't work. I cannot divide by -1. Same thing with 4. If I plugged that in, I'd plug it in for all the x's, not just this one. But if I plugged it in everywhere, I would get -1 over 5 times 1. So that would, times 0. Sorry, 4 minus 4 is 0, not 1. So that would also give me 0 in the denominator, so it can't work. So if it just says find the points of discontinuity, you're done. You've got x equals -1 and x equals 4. But if it asks you to determine if they are vertical asymptotes or wholes, we have to then use the numerator. So this is from my denominator. And you only have to compare it to the numerator again if it asks are they vertical asymptotes or wholes. So with the numerator, I set that equal to 0. And I get x equals 5. So comparing my my answers here with my answer over here, none of those match. This is a different number than either of the points of discontinuity, so it is not relevant in this case. Neither of these match the numerator, so that means that there are no wholes. There's only a whole if the numerator and the denominator match. And we can say that there are vertical asymptotes at x equals -1 and then x equals 4. Please write each of these individually. Do not just, if you just put this, I'm going to take off a point. I want to be very clear about the asymptote is at x equals -1 and x equals 4 because an asymptote is an equation of a line. Let's look at another example. Go with some fuchsia power. So if I had something like this, give me a second to do some quick math. Okay, so let's say I have this. What I'm going to do is start by setting my denominator equal to 0. This one's a little trickier. It's not factored for us, and so we have to factor it. So remember, when we factor, we draw our two sets of parentheses, split up our x's, 3 and 1 multiply to 3 and also subtract to 2, and this sign goes with the bigger number because they're going to be different. So to keep solving, I would say x plus 3 is equal to 0, x minus 1 is equal to 0. X equals negative 3, x equals 1. So here are my two answers. I know that these are points of discontinuity, but now if it just says, are they points of find the points of discontinuity, you're done. You've got that part. But if it asks, are they vertical asymptotes, are they wholes, that's where we're going to bring the numerator in, and we're going to say x plus 3, that should be a plus, equals 0. And we're going to say, okay, I get x equals negative 3. Well, when I compare that, I see that suddenly this and this are the same value. So what that means is that because they're the same, I have a whole at x equals negative 3 and a vertical asymptote at x equals 1. X equals 1 did not have a buddy in the numerator, sad face, and so that means that it's just a vertical asymptote. Whereas negative 3, it had a friend up there, and so it makes a whole. Okay? Let's do one more. Excuse me. Let's do okay, we'll do this. So for my denominator, I hope this works. I just made that up off the top of my head. For the denominator, I'm going to have x squared plus 8x plus 12 equals 0. Factoring, split up our x's. What multiplies to 12 and adds to 8, that would be 6 and 2. Same sign, both positive, equals 0. So I've got x plus 6 equals 0, and x plus 2 equals 0. That would give me x equals negative 6, x equals negative 2. All right, so now we have our numerator. And so we're going to have x squared plus 36. Oops, I'm going to change that real quick. Sorry. Minus, my bad. And we're going to get, I don't want to factor it. I just want to solve it using square roots. Equals 0. So I'm going to get x squared equals 36. X equals plus or minus 6. So if I write that out so it's a little clearer, I have 6 and negative 6. And I see that negative 6 and negative 6 are in common. So that means that I have a whole at the place they have in common. X equals negative 6. And then negative 2 does not match with anything in the numerator, so that makes it a vertical asymptote. Now, there's this value of x equals 6 left in the numerator, but it doesn't mean anything. If I plug in 6, I get 6 squared minus 36 over 36 plus 48 plus 12. And it doesn't even matter what I get in the denominator because I get 0 over who knows what. But I can divide by 0, so I get 0. That's a valid answer. Whereas if I were to plug in -6 or -2, I would be dividing by 0. And I can't divide by 0. So my answers would be whole at -6, x equals -6, and vertical asymptote at x equals -2. Solve for your denominator, set it equal to 0 and solve it. Those are your points of discontinuity. Point 1, point 2. Irrelevant. This is only relevant because it matches with this guy here. So let the denominator be the thing that determines if you have a point of discontinuity. Use the numerator to check if you have any wholes or vertical asymptotes and what kind of point of discontinuity it is. I hope that helps. I'll be around tomorrow if you have more questions.